Section 3.1 is solving systems of equations through graphing. And the reason that I'm not going to spend up, well, I'm really not going to touch on that, is because when we graph sometimes, what we're looking for when we're solving a system of equations is we have two lines or two or more lines. And we're looking for the one point that those lines have in common with each other. So we're actually looking for an ordered pair on a graph. Now sometimes when we graph, we come across something that may crisscross right there. And on a graph, what is that? Is that 1 and, I don't know, 1 1/5, 1 2/3? What is that? Okay, so sometimes it doesn't cross at a specific point, and so we don't have an exact answer. So what we're going to do is we're going to get into substitution today where we can find an exact answer. So solving systems of equations, you have two or more lines, equations of lines. Let's review. What makes the equation of a line? What letters or how many letters are in the equation? 1 or 2, correct? Different letters. Usually it's X and Y. Sometimes it may be other letters because it may be reflective of a relationship between, say, cats and dogs, and they may use C and D. But still, it's a relationship between two things that exists. So we're looking for the point where those two lines cross each other. So our answer is going to be as an ordered pair. Okay? All right. But getting into section 3.2. James, can you come calibrate? I just discussed 3.1. It's solving by graphing, but we're not going to concentrate on that. We're going to learn how to find exact solutions. Okay? Put on the middle of the dot. Pretty. Thank you. All right, and I'm going to show you how to set it up because what you're doing when you're solving through substitution is you're working through a cycle, okay? And so to make sure that we get our cycle completely done, I have a little way of doing that. Let's go on to the next one. Okay. So the first ones that we're going to look at is here. X plus 2y equals 8. And this is the equation of a line. And the second line is 1/2 x minus y is equal to 18. Okay? Now, I cannot solve either one of these equations alone and get x as a number or y as a number. Because if I try to solve this equation here, for x, I don't know what y is. If I try to solve it for y, I don't know what x is. So if I have two unknowns, I need two equations so that I can put them into each other and substitute. Now remember, we've said in the past, if x is equal to 4, what does that mean? What can you do through substitution? You can plug a 4 in everywhere you see an x, okay? Well, if x is equal to 4 minus y, what can you do? Plug a 4 minus y in everywhere you see an x. So our starting point for solving this system of equations is to look at every single variable in both equations and decide which one takes the least number of steps to get it by itself. Would it be this x? How would we get this x alone? Subtract 2y from both sides and we're done, right? Would it be this y? How would you get that y by itself? You'd have to subtract x and then divide by 2, therefore creating fractions. Okay, so we don't want to do that. Over here, same thing. It's going to take more than one step to get either one of those variables alone. So the easiest one to solve for is the x in the first equation, correct? All right, so first thing we're going to do is find out what is x equal to. Well, x is equal to 8 minus 2y. Does everyone agree?
Yes, ma'am.
Because all I did was subtract 2y from both sides. I am ready to start my cycle. If x is equal to this expression, then I can take that expression and substitute it into the other equation for x. All right, so here's my cycle. I'm taking my expression and I'm going to substitute it into the other equation for x. So now I have 1/2 times the expression that x is equal to, 8 minus 2y, minus y is equal to 18. Now what have I accomplished by plugging that in? You only got one variable now. So now I can actually find out what y is equal to. All right, well, let's solve for y. What's the first thing we need to do? We need to distribute 1/2. Half of 8 is? Half of 2 is? But it's going to be a negative 1y. And then I still, on the back side, do I distribute the 1/2 to the negative y over there? No, it's not in the parentheses. It's not in the group. So this is also minus 1y equals 18. Next, I'm going to combine my like terms on this side. So negative 1 and negative 1 is negative 2y. In the same step, I want to get this 4 on the other side. So what am I going to do? Subtract 4 from both sides. And that leaves me with positive 14. 18 minus 4 is 14. And then divide both sides by negative 2. And you find that y is equal to a negative 7. But remember, we're looking for the coordinates of an ordered pair. So what do we need to know now? And here's how we finish off our cycle. Notice it's kind of funky looking, but it's a circle because we take one equation, plug it into the other, and then once we find an answer, we go back to the first one. Doesn't matter which one you do. But to keep your circle going straight, because you already set this x equals, now you just got to plug in and figure it out. Yes, ma'am.
Why couldn't you use that to for that equation instead of like what you got for x?
Why couldn't I plug this in to this? I could. Actually, no, I couldn't. Because I'd just end up with 0 equals 0. Okay? Because if I put that here, the negative 2y plus 2y goes away, and 8 equals 8. All you've done is you've taken something and plugged it right back into itself. So you've said that all numbers will work. Okay? You have to plug it into something else. You have to have something else, another relationship to plug it into. So then I come back and I finish off here. If x is equal to 8 minus 2y, and y is negative 7, then x is equal to 8 plus 14, right? Because I do my multiplication first. So x has a value of 22. Now remember though, this is an actual point on a graph where two lines are crossing each other. So how do we label points? We label points as ordered pairs, right? Where the x coordinate comes first and the y coordinate comes second. So this is how your answer should be written, as an ordered pair. So these two lines cross each other in which quadrant? 22, negative 7, the fourth quadrant. The fourth quadrant, where x is positive and y is negative. In the fourth quadrant is where those two lines are crossing each other. Okay? All right. Let's do another one.